Okay, so what we're on now is section 1.4b, which is called IVT, stands for the Intermediate Value Theorem. We'll write that down in a moment. But we're starting with this quick definition of continuity on a closed interval. And the reason that I mentioned this definition, I just scooch this up just a tiny bit more. There, better. All right. The reason I'm mentioning this definition before we get into the intermediate, oh, it's going to be fun watching these videos. Okay, that's good. Okay, the reason I get into this definition is because the IVT does require that a function be continuous on a closed interval. Oh, go for it. That's okay. That's what's good about live filming.
JP, you got me? After you.
It's not working.
Here.
Dude, you gotta believe.
Here. It might not be pleasant. Take this.
Thank you. I'll give it back.
There you go. There you go. Okay. So here's the thing. We all know our three conditions for continuity are that the function has to be defined, the limit has to exist, and they have to equal each other. Well, the limit can't exist at an endpoint. Because for a limit to exist, it's got to be the same from both sides, right? And at an endpoint, there's only one side. So how do we say that a function is continuous on a closed interval? Well, they came up with this definition for continuity on a closed interval. And what it says is, if it's continuous on the open interval from A to B, and at this end, the right-handed limit equals the endpoint, and at this end, the left-handed limit equals the endpoint, then we're good. So then they consider the function continuous on the closed interval. So for this case, when you're talking about continuity on a closed interval, you can't be continuous at an endpoint, but you can have right and left-handed limits. So they just say for the endpoints, if that limit from one side approaches the endpoints, we're good. Does that make sense? Okay, so that's what we mean when we say a function is continuous on a closed interval. Just so that when I write this down, you don't all go, oh, it's continuous on an endpoint. Oh no. Okay, so it's time to learn the Intermediate Value Theorem. And we're going to write the theorem out first. It's also known as the IVT, and I will pretty much always call it the IVT after this. And here's what it says. If f of x is continuous on the closed interval AB, and k is some value between f of A and f of B, then there must exist at least one value C in A, B, such that f of C equals k. Oh yeah, there you go. Now remember, every theorem is a conditional statement. It's an if-then statement. The stuff after the if, those are the conditions, the requirements for the theorem to apply, and then the stuff after the then is what you get from the theorem when you apply it. So in this case, there are two conditions. F of x has to be continuous. That's a given right out of the box. The function's got to be continuous on that interval or the theorem doesn't apply. And then the second condition is there's some number k that has to be between f of A and f of B. Now my first question to you is k an x value or a y value?
Y value.
How do you know it's a y value?
Because it says that one value of C and it has C plugged in for f of C.
Oh, okay, yeah, you got that from over here. Very good. Okay, another way to say say is that k has to be between f of a and f of b, and those are y values, right? So k is some y value between f of a and f of b. So k is a y value. C, what is C? C is an x value, because C is inside of our interval, and these intervals, of course, are x values. C is an x value. C is an x value. Did y'all get that? All right, I'm going to rewrite the theorem in plain English, and then I'm going to show you what it means on a graph, just so you can see what we're talking about. Because sometimes you can read a theorem, but you don't actually know what it really means. All right. Okay, so in plain English, let's see, for a continuous function, it must pass through every y value between the endpoints at least once. So if a function is continuous on a closed interval, then it has to hit every y value in between the endpoints at least once. To get from A to B, you got to hit every y value in between at least once in that interval. You can hit them more than once, but you got to hit them at least once. There's no way around it. Everyone's, can you think of a way around it?
A circle.
That's not a function.
No, my bad.
Okay. Yeah, there's no way around. So, graphically, you just think to yourself, all right, so I have some f of a, that's a, and I have some f of b, and then what's going to happen is you're going to be given some value k. So say you're given some value for k that's in between f of a and f of b, then there has to be at least one spot, and there can be more than one, but at least one spot in between these x values where the function hits that y value. And we would call the x value where it hits, we would call that c. Okay. All right, so first types of problems that we're going to do are in your homework quite a bit. And here's what they say. So here's our first example. Use the IVT to show there is a 0 in the interval 0 to 1 for f of x equals x cubed plus 2x minus 1. It doesn't say to find where it is. It doesn't ask you to find c. It just says show that there has to be a 0. All right. So in order to use the IVT, the first thing we have to do is check to see if our two conditions are met. What is the first requirement for us to be able to use the IVT? F of x has to be continuous. Is f of x continuous? Can you guys look at that function and determine if it's continuous? Yeah, it's continuous. You don't have to prove that it's continuous. In this class, we don't have to prove continuity. We have to prove discontinuity, but not continuity. But you do have to show me that you checked it. So here's what I'm going to be looking for. F of x is continuous on the closed interval 0 to 1 check. Okay, so I'm gonna look for the two checks, there are two requirements. So number one, f of x is continuous on that interval. Second thing I'm gonna look for is the second requirement, which is k has to be between f of a and f of b. What is k for this problem?
C.
It's gotta be a number.
Oh,
Is k 1?
it's 0.5.
K is a half? It's gotta be given, you can't guess k. K is 0. When we want to show that there is a 0, that means that there has to be some spot, this is some cubic function, right? When we're talking about a 0, we're talking about a y value of 0, right? When it's on the x-axis, that's when our y value is 0. So our k for this problem is 0. So now we have to find f of a and f of b. Everyone take a second and find the function value at the endpoints. What's f of 0? Negative 1. What's f of 1?
2.
F of 1 is 2, right? Is 0 in between negative 1 and 2? Yeah. So f of 0 is equal to our k, less than or equal to f of 1. Or you can just write 0 is in between f of 0 and f of 1, because they can go high to low, they don't have to go low to high. So, but you checked that it's in between. So, check, check, two checks. Therefore, by the IVT, there must be a 0 for f of x in the interval 0 to 1. It didn't ask you to find it. If it did ask you to find it, we'd have to set this function equal to 0 to find what x values were, but it's a cubic and I'm not going to ask you. Yes, Fran?
I'm not quite sure how we arrived at k equal to 0.
Because they have to tell you what y value you're interested in, and the only y value given here is 0. Show that there is a 0. So here's what it's saying, guys. In essence, what it's saying is we have a continuous function between 0 and 1. F of x is below 0 here, above 0 here. So because it's continuous, by the IVT, it has to pass through 0 at least once in that interval.
So for that graph over there, the x-axis be at k?
For this graph,
No,
k,
is that part of this question?
no, this
Oh,
is just
okay.
me demonstrating
Okay.
what the IVT meant in a nutshell.
Okay.
Yes.
That's something else.
Okay. Do y'all kind of get a feel for what it's going for? Let's, well, I'm gonna give you a different one. Oh, I want to do one more of these. I'm gonna give you, let's do one more of these real quick. Alright, so let's do, I'm gonna change the example I did first period. I'm gonna have you find C also. Okay, so use the IVT to show that there is a 0 in the interval from -3 to 0 for the function f of x equals x squared plus 7x plus 6. Then I want you to actually find C. Take a second in your groups. Make sure you write down your two conditions that have to be checked. write your answer and find C. You can all write your first condition without really thinking a whole lot.
-3 is less than 0 is less than
What's the first thing you have to write no matter what? F of x is continuous on the closed interval. It can be discontinuous outside the interval. It just has to be continuous on that interval. Alright, check. Everyone write that?
Yes.
Okay, that's worth at least a point, right? Next thing, we know our k. What's k? 0. So next, what do we have to find? F of -3 and f of 0. What was f of -3? -6? What was f of 0? 6. Therefore, by the, oh, I gotta write down that it's in between. So I would say -6 less than or equal to 0, less than or equal to 6, check. Or you could put f of -3 and f of 0. Therefore, by the IVT, there must be a 0 for f of x on this interval. Now, we have to find c for this one. In order to find c, you actually have to take the function, set it equal to 0, and solve. So if we factor, we get x equals -6 and -1. Our c is just -1. Why? Because we restricted this domain of this function to we're just focusing on -3 to 0, so that c value needs to be inside of that interval. That's why we say in our form or in our theorem, c has to be in that interval, in the interval AB. All right, one more, taking it up a little notch. I will tell you guys, most of the homework problems tonight deal with using the IVT to find zeros. There will be some where you don't. Such as, verify the IVT applies to g of x equals x squared plus x over x minus 1 on 5 to 4 for f of c equals 6. Then find c. Okay, take a moment to copy. Oh, I'm so sorry.
No, what happened?
don't know why I wrote it as close to that. Close.
That was messing me
Did
up.
that throw you off? I'm sorry.
Yeah, I was like, why?
I was just about to copy that down. Mistake.
So what's the first thing we need to check?
It's continuous.
If it's continuous, is this function continuous?
Yes.
It is on the interval, isn't it? So it's okay that it's discontinuous at 1, because 1 is not in our interval. All right, so yes, continuous on 5/2 to 4, check. Next thing we need to check, what's our k value for this? 6. So we need to find g of 5/2 and g of 4. I'm going to walk you through this real quick. Because, of course, we won't have a calculator, right? So g of 5/2 equals 25/4 plus 5/2 over 5/2 minus 1. I personally don't want to sit here and combine all these fractions, right? So instead what I'm going to do is I'm going to multiply the whole top and the whole bottom by my LCD of 4. And I'm going to get rid of all my fractions within fractions. So what I end up with is 25 plus 10 over 10 minus 1. So I get 10 minus 4, sorry. So I get 35 over 6. G of 4 is 16 plus 4 over 4 minus 1, which is 20/3. Let's convert it and make it 40 over 6. Is 6 in between 35/6 and 46?
Yes.
Yes, because 6 is 36/6, right? Okay, so what we've said then is we've said, all right, g of x is continuous on 5/2 to 4, check. 35/6 is less than or equal to 6, which is less than or equal to 46, check. Check, check. Therefore, IVT applies. And that was our first part of the problem, just verify that it applies. The second part then is to find C. So you have to actually set your function equal to 6 and solve. How are we going to solve this lovely rational equation?
So it's equal to 0.
Set it equal to 0. Okay, that's a good thought.
Multiply both sides by x minus 1.
I would multiply both sides by x minus 1. Which is kind of the same thing as what you'd get if you cross multiply, right? So x squared plus x equals 6x minus 6. What do we do from here?
Factor out the x. And use,
Combine.
That would be what we would do if we wanted to get a really nice BA. What do we always do with a quadratic? Gotta set those quadratics equal to 0 first. Always. X squared. It's very tempting to factor out those x's though, I get you, because there's a lot of people that did it. It's minus 5x plus 6 equals 0. We have to get equal to 0 before you factor. Always gotta be set equal to 0 before you factor, right? So minus 2 minus 3. So x is 2 and 3. What's the only value for c?
3.
Why is c only 3? Because it has to be in the interval, which means it has to be a number between 2.5 and 4. So 3 is the only one that works. All right, so in summary, what have we learned today? All right, so IVT, there are 2 requirements. The function has to be continuous, and the k value has to be in between